emission. And also it enhances the durability characteristics, and it is found that improves the strength at later ages. Impact resistance. Impact resistance is the ability of a material to withstand a high magnitude of force or shock applied to it over a short period of time. A force of larger magnitude over a short time has a greater effect than a force of smaller magnitude over a longer period of time. Impact strength acts as a critical part in structures like bridges, harbors, crash barriers, fencing posts, curbs, etc. That is, areas which are prone to road accidents, also structures at the danger of blast loading or natural disasters. Need for study. So we know cement enterprises are one of the fundamental drivers of global warming, as they are the principal donors of carbon dioxide. It is the need of the hour to adopt a material that reduces the carbon emission and consumes less energy during their production. Usage of GGBS in conventional construction practices helps to reduce carbon dioxide emission, and it is also an effective utilization of industrial byproduct. Threats like blast loads, accidental explosions, natural calamities, etc., which results in impact loading on structures, needs to be investigated. And limited literature is available on the impact resistance of GGBS mortar. Objective: to identify the effect of addition of GGBS in improving the impact resistance in mortar mixes, to study the properties of materials and arrive at a suitable mix proportion, to identify an optimum mix, to identify the microstructure of GGBS in mortar by conducting SEM analysis. Methodology: literature review, investigation on material properties, identify the mix proportions, study on impact resistance, microstructural studies, and discussions and conclusions. Material properties. Cement, 53 grade ordinary Portland cement is used. The properties are tested and is tabulated, and also the chemical composition is shown in the figure. GGBS, it is bought from Quality Polytech Mangalore, and the properties as supplied by the supplier is shown here, and its composition is depicted. Then fine aggregate is used, M sand, which is collected from a local quarry in Calicut. The properties are tested in the lab, and it is found that it conforms to grade of zone 2. Then superplaster, Conplast SP430 is used in this study, and its properties as supplied by the manufacturer is tabulated. Also, potable water is utilized in this experimental study. Mix proportions. Guidelines for the preparation of mortar is according to IS 22501981. Proportioning is done using trial and error method depending on the parameters, namely amount and properties of binding materials, concentration of superplaster, and flow value. A mixed proportion of 1:1.5 is taken for this study, which is approximately equal to M20 grade that can be conventionally used as per the recommendations of IS 456-2000. A water cement ratio of 0.35 and superplaster content as 0.5% of binder is taken. In this investigation, the cement was replaced with 20%, 30%, 40%, 50%, 60%, and 70% GGBS on a mass for mass basis. The amount of fine aggregate, water cement ratio, and superplaster were kept constant in all the mixes. The table shows the notations for various proportions of the mix. For under percentage OPC, that is the reference specimen, is depicted as OPC. Then for 20% replacement of cement is depicted as G20. Similarly, for 30%, 40%, 50%, and 60%, 70% are depicted as G20, G30, G40, G50, G60, and G70 respectively. Fresh properties like consistency, setting time, and workability is studied, and the results are tabulated. And it is observed that consistency increases as percentage of GGBS content increases. Addition of GGBS does not significantly affect the setting mechanism. Workability increases as percentage of GGBS content increases. Then a study on hardened properties is done to understand better the mechanical behavior of mortar after the inclusion of GGBS. Compressive strength tests, split tensile strength, and flexural tests are carried out on mortar, which are cured for 28 days in water. The results are tabulated, and it is observed that the result of the 28-day compressive strength test shows that addition of GGBS up to 50% provides strength almost equal to OPC mix. Also, in general, there is a significant improvement in the flexural strength and split tensile strength with the addition of GGBS up to 50% and reduces thereafter. And this may be due to, from literatures, this is due to the presence of unreacted GGBS acting as a filler material in the paste. Then study on impact resistance. Usually large scale missile impact test, etc., is technically difficult and it is very much costly. So we are focusing on small scale drop weight impact test, which is done according to ACA recommendations 544. So the specimen chosen is a disc of diameter 100 mm and height 50 mm. Specimens are cured for 28 days. The setup is shown in the figure. It consists of a load of 4 kg, which is dropped from a height of 457 mm, and making impact energy of 17.93 joule per hit. And impact energy is determined using the equations E is equal to N into mgh, where N is the number of blows at failure, M is the mass of the steel ball that is used, then G is acceleration due to gravity, and H is the free fall height. So here the number of blows causing the first crack and the number of blows at the failure is calculated from the taken from the test, and the results are tabulated in the column. So this graph depicts the variation of impact energy by the addition of GGBS and replacing the cement with the reference specimen OPC mix. And from that, it is inferred that maximum impact energy was observed for G50 mix, which is 18.33% more than OPC mix. G60 and G70 mix is having a low impact energy compared to other mixes. Also, G60 mix has 47.49% lower impact energy, and G70 mix has 53.33% lower impact energy than the OPC mix. These are the figures showing the failure crack patterns, and a brittle failure is found from the surface of the specimen, and which breaks into two halves. Microstructural studies. So scanning electron microscopy is technique is used here, and it is done according to ASTM C172316. Then facility at Stick Kusat, Kerala is used to study the form of OPC mortar mix and G50 mortar mix. Then the specimens after 28 days curing is taken for semi-analysis. These are the images obtained for OPC mix and for G50 mix respectively. Here the notations A is denoted for the pores, then B for unreacted or partially reacted slags, and C for the smooth surfaces, and D for the air voids. So it's observed that SEM image for G50 mix shows that more smooth surfaces indicating the fineness of GGBS. Then more pores are identified in OPC mix. Thus, the finer GGBS particles combined with greater particle of the cement, enhancing the mechanical properties of the mortar. Also, G50 mix has a denser microstructure compared to OPC mix, resulting more impact energy than the OPC mix. Some unreacted, partially reacted particles were also observed in both the mixes, and air voids are also visible in the case of OPC mix. Conclusions. So this study is an experimental investigation on the impact resistance of GGBS mortar. Studies on the impact resistance of GGBS mortar shows that GGBS can be effectively utilized as a raw material on structures like railway sleepers, crash barriers, fencing posts, curbs, etc., which are mostly subjected to impact loadings. From the test results, the following conclusions are made. The inclusions of GGBS in mortar improves the mechanical properties significantly. The inclusion of GGBS up to 50% improves the impact energy by 18.33% when compared to OPC mortar. Some analysis shows that G50 mix has a less porous structure and has more smooth surfaces, indicating a denser microstructure. The studies on the hardened properties indicates that G50 mix can be taken as an optimum mix. Future scope. This study can be expanded to real-life structures for a better understanding of the performance under impact loading. Also, investigation related to the durability of GGBS mortar in extreme conditions and its corrosion resistance can be studied. These are my references. Thank you. Thank you, ICSMC 21, for giving me this opportunity.
Thank you, Gitu Ilasa, for this presentation. And now I would like to ask
Thank you, sir.
uh, audience to raise their questions. If some questions are required, they may write in the chat box. So it's this is for all other participants also, that if some questions they want to ask from the author, they may write in the chat box, that will be read by us, and then that will be subsequently answered by the author. So just one query from my side uh,
Yes,
for
sir.
this work which you have done. Uh, so why this my own query, that why you are working on such a lower grade of concrete for M20? Why not you are using for higher grade?
Sir,
Is there
actually,
some specific reasons for that, or you are just you are doing as for your convenience?
uh, actually we planned for conventional mixes. We use M20, so that's why we have taken M20 in the study.
But since you are using such a huge plasticizers, also you are replacing cement content. So M20 grade of concrete, obviously, uh, I don't
Uh,
think that it's a very minimal amount of compressive strength. Is almost you will get 20 to 23 if you design properly. So
Sir,
yes,
actually, sir, this is a part of my PhD thesis work. So in that, I have to take M20 mix. So as a sub part only, I am doing this work. So that's why I continued the research with M20 only.
okay, okay. And
Thank you,
another
sir.
thing is that GGBS has some issues, that GGBS, it promotes faster carbonation rate. So that will effectively it will affect the durability aspect of the concrete also. So as per your research, you are claiming that that will help the microstructure of the concrete has been drastically improved, and so how you will overtake that if the carbonation rate increases?
Sir, actually, the second part of my work, I am planning to do the durability studies. So I have to check with that. But till the first stage, from microstructural studies, it is observed that its strength is being increased. The microstructure is becoming denser than that of the OPC mix.
Okay. So, anyone else who wishes, Shreyas Pranav, he has actually missed that point
Yeah.
of microstructure. Is only SEM done, or something else is also done? He is asking that you have only done the SEM part, or anything else you have done.
Uh, SEM analysis is only done now. I have given the for conducting XRD analysis also. So due to the pandemic, the results are lagging. Uh, so that will be also seen.
Okay, okay. Abhilash sir, Abhilash sir, if you wish, you can ask.
Can you hear me properly?
Y- Yes, sir.
Yeah, I have one question. You talked about the impact resistance using ground granulated blast furnace slag, right, in your PPT.
Yes, sir.
So, how you are going to evaluate it?
Um, Sir, I have calculated the impact energy as per the formulas given in the code, and we are comparing based on the impact energy, how much impact energy is increasing, because how much the number of blows are required for the final failure of the specimen in
And one more
uh,
and
the
one more
test.
question I want to ask. Don't you think SEM analysis has become a traditional method for characterization or for looking at the microstructure of cementitious and cement-based systems? Don't you think?
Yes, sir. SEM analysis is useful for understanding the pores, the voids. Then even though cannot observe the chemical elements or chemical compositions, but we can understand.
There are some other methods which give you a comprehensive idea of your sample, not only the pore size, but also the involved systems in it. So you have to explore a bit so that you can get a good comprehensive idea. Okay, that's all suggestions from my side. All the best.
Thank you, sir. Thank you, sir.
So thank you.
Yes, sir. That's from my side.
Thank you, sir.
For this wonderful presentation. You may our next paper ID is 116. So I would like Anurag to upload his presentation. Paper ID 116.
Yes, sir.
Anurag, please.
Good morning, everyone. I am Anurag from Thapa Institute of Engineering Technology, and the title of my paper is Optimization of Clinker Factor for Low Carbon Pentabladed Cement Mortar via Box Bankum Design of Response Surface Methodology. And these are the outlines of my PPT. First of all, I will cover the introduction part, then the need of study, and then the objective. After that, I will cover the materials used in the research work and the methodology and the results and discussion part. After this, I will conclude my presentation. Coming to the introduction part, if we talk about the Portland cement, the manufacturing process of the Portland cement requires about 1400 to 1500 degrees Celsius temperature. And with this amount of temperature and with this manufacturing process, a lot of harmful gases are emitted into the environment, which leads to degradation of the environment. Whereas if we talk about the low-grade limestone, it needs only 900 degrees Celsius of temperature for its calcination. And with this temperature, a low-grade limestone attains the pozzolanic property. And also with this temperature, we can have the lesser emission of harmful gases. So low-grade limestone is the alternate in the cement industry, which should be used as an SCM. So in my present research work, I have used the low-grade limestone and its calcine form along with other two SCMs, Silica, Fume, and fly ash. And then what is the need of this study? Actually, we can have our limestone from the waste. There are a lot of sites in the Rajasthan where this low-grade limestone slurry is dumped into the open landfills, which degrades the land. And this is the picture of Rajasthan where it is dumped into the open landfills. And also from this stone polish waste from the cutting industries and polishing industries, it is dumped into the open landfills. This is the picture of the deposition of this slurry, which is a huge. So the impact of this slurry in the open landfills leads to the loss of agricultural land, which contaminates the groundwater. What are the objective of this research work? The main objective is to produce the low-grade calcine limestone by heating the calcine limestone at a temperature of about 900 degrees Celsius for about 1 hour, and to determine the optimum dosage of these two uncalcined and calcined limestone, which can enhance the properties of mortar. And also we have to use it in the maximum so that open landfills dumping should be minimized. And we have to compare the properties of control mortar with the composite cement mortar. And after all these things, we can have a final mix of our mortars, which can enhance all the properties. And by the use of the design expert software, we have reduced the number of experiments, because we have 5 input variables: calcined limestone, fly ash, uncalcined limestone, silica fume, and super plasticizer. And if we make a combination, we can have 243 mixes, but with the help of design expert software, we reduce these mix to 46. So number of trials are reduced. So these are the materials to prepare the mortar. First of all, binder and sand, water, and super plasticizer. In the binder, I have used OPC 43 grade, which was obtained from the Cement Corporation of India Limited, and the fly ash collected from the NTPC Dadri. Silica fume was collected from the Japan Aerosil, and uncalcined limestone from the Kota, Rajasthan, and calcined limestone we have prepared at the CBRI Roorkee. Sand was collected from the Roorkee, and water we have used the potable water, and super plasticizer was Master Galenium 51. These are the experiments that I have performed. First of all, I have prepared the calcined limestone in the furnace at a temperature of 900 degrees Celsius, which is withstand for about 1 hour, and then quenching was done, and I have used it after 24 hours with after this calcining. And these are the tests, fineness test I have performed, and flow table test for determining the water content. And this is the preparation of mortar, the DG mortar mixer, and these are the cubes for the compressive strength test. Coming to the result and discussion part, first of all, these are the SCMs that I have used. FA stands for fly ash, UCLS stands for uncalcined limestone, CLS stands for calcined limestone, and SF stands for silica fume. The replacement levels of these input variables are these. For fly ash, I have 5%, 20%, and 35%. For the uncalcined, I have 5%, 10%, and 15%. And similarly, for the calcined limestone and silica fume, I have 3%, 6%, and 9%. These replacement levels are based on the literature survey. We have done literature survey, and these are collected from there only. And I have conducted a fineness test, and these are the fineness of each SCM. And I have concluded that by the use of these SCMs, the fineness of composite cement was increased, because this fineness of all the SCMs are very, very high as compared to OPC. So resultant is the fineness was increased. If we talk about the consistency, all the SCMs increases the consistency. If we talk about silica fume and calcined limestone, at every replacement level, the consistency was increased. But if we talk about fly ash, uncalcined, and super plasticizer, the only dosage is 5% of fly ash and 5% of uncalcined limestone, and 0.5% of super plasticizer results into the increase in the consistency. Whereas if we increase the dosage of these input variables, consistency leads to the downfall. So these are the only dosages which can enhance the consistency. If we talk about setting time is increased with the inclusion of these dosages: 35% of fly ash and 5% of uncalcined limestone, 15% of calcine, 6% of silica fume, and 1.5% of super plasticizer leads to the retardation of the setting time by about 30% as compared to the control mortar. And if we need the acceleration in the setting time for the areas where we need this acceleration, where we want the our mortar to set quickly, then these are the dosage of the these input variables. We can have reduce the fly ash to 5%, and UCLS is at the same level, 5%, and the CLS reduced to 10%, silica fume reduced to 3%, and SP increased to 1%. So this is the replacement level if we want the acceleration setting time. If we talk about compressive strength, so we know that with the addition of fly ash, 28 days compressive strength decreases. So at a very lower level of fly ash was used here, and uncalcined limestone was 5%, and 15% of calcined limestone. This is the maximum usage of calcined limestone we have used. So, and 9% of silica fume and 0.5% of super plasticizer increased the 28 days compressive strength by about 62% as compared to control mortar. And this is the mix by we can reduce the clinker factor to 0.66, which is the effective. So we have reduced the clinker factor by this mixture. And after that, I have optimized the optimization of the process. So these are the input variables. So lower limit was fly ash for 5% and upper limit was 35%. And similarly for uncalcined limestone, I have a lower limit of 5% and the upper limit for 15%. Same for calcined limestone. And silica fume was have a lower limit of 3% and upper limit of 9%. And SP was having lower limit of 0.5% and upper limit of 1.5%. So we have optimized these outputs. So we want the fineness in the range of 300 to 500 and consistency in the range of 30 to 36, and we have initial setting time in the range of 30 to 120, and we want final setting time in the range of 200 to 600 minutes. And compressive strength, 28 days compressive strength, we want it is in the range of 43 to 65. So after these input these in the design expert software, software give us 100 solutions which can which have these properties which we want. So 100 solutions were obtained from the software of design expert. So out of these 100 solution, we have one best solution which is this with the maximum desirability is 09.927, which is very closer to 1. So this is the mix which can enhance all the properties by using 4.25% fly ash, 6.14% of uncalcined limestone, 15% of calcined limestone, 5.84% of silica fume, and 1% of superplasticizer. We can see that these dosage are quite different as we input in the software. So this is the optimization process. These are the input variables. These are the dosage levels which software gives us, which enhances the strength. This is the plot where we can have the desirability of 0.927. This is 3D surface plot. We can use the our fly ash in the range and uncalcined limestone in the same range. So maximum utilization of uncalcined limestone and calcined limestone was there along with the silica fume and fly ash. This is the overlay plot. This is the area where we can have our enhanced property. Every line represents each properties of the mortar. So this is the area where we have our enhanced properties of cement mortar. So after having this mix, we done the experiment again. We performed the experiments again, and these are the optimized values obtained from the results. And these are the experimental values that I have performed the experiment, and these are very near to the optimized value. So this is the error which was very less. So concluding this, we can have the if we use the low grade limestone along with the OPC and other supplementary cementitious materials, we can enhance the properties as compared to the OPC. And this is the better eco-friendly option as compared to OPC, as I have told in the first slide. And we obtain the exact replacement levels after the optimization, which can enhance all the properties. And calcination imparts the positive properties of limestone. And clinker factor was reduced to 0.66, which is very beneficial. Thank you.
Thank you, Anurag, for this presentation. So now this forum is open for question answer round. Anyone who wishes to ask any question may write in the chat box that can be read. Abhilash sir, if you wish, you can ask.
Yes, I want to ask some couple of questions. Mr. Anurag, can you hear me?
Yes, sir.
Yeah. So you have said that use of low grade limestone,
Yes, sir.
and mixing with them with the SCMs
Yes,
is a viable option than using OPC, right?
Yes, sir.
So in our cement plants, when I visit some cement plant, visited I think a lot of cement plants. So they have a good amount of limestone reject. Do you understand limestone reject means? They have not been using those limestones for the production of cement. Okay, they are rejecting those particular limestone.
Okay,
Now, have you found any codal provision to use those limestone reject
No,
before
sir.
framing your methodology for your
Yes, sir.
research?
Yes,
Have
sir.
you gone through some BIS coded provisions?
No, sir.
Okay. My second query is that you have used super plasticizer and told that there was an enhancement of strength,
Yes, sir.
correct?
Yes, sir.
So, do you agree that using of super plasticizer really increases the strength? Is it due to the addition of super plasticizer?
No, sir. Super plasticizer was only used for the reduction in the water content, sir.
Reduction in the water content.
Yes,
Does
sir.
it not increase strength? That is what you're telling?
Sir, it has a very less impact on the strength, not more, very less impact on the strength, sir.
Then what does it have impact on? When you're adding something into some particular system, it
Yes,
will
sir.
have some impact. So what things it will have some impact? Does it have any impact on hydrated products?
Sir, it has mainly impact on the lower of the water content and some impact on the strength, enhancement of the strength, sir.
Okay, that's all. Thank you. And Saurav sir, you can take over.
Thank you, Anurag, for your presentation. Now I would like to introduce Aman Kumar, paper ID 53, to upload his presentation and start.
Good morning, sir. Sir, I had a request. Can I keep my video turned off? I'm in Chennai and there has been like a very heavy rainfall here, so network is not so good.
No
Yes,
issues.
yes, yes, definitely.
Thank you, sir.
Anurag, you please mute yourself.
Good morning to one and all present here. Today, I, Aman Kumar, am going to present on the topic leaching and heavy metal binding characteristics of red mud based construction materials, a review. I'll be first going through what is red mud and what is the objective of this study. Moving towards the experimental methodology that has been used in the works of the various authors referred to in this study. Then I'll be presenting the results of some of the tests carried out and finally discussing the conclusions that can be drawn based on the study. The number on your screen, that is 2,700,000,000 tons, is the global stock of red mud in the year 2007, which has since been increasing at a rate of 120 million tons per year. Now, why should we be concerned about this number? Formerly known as bauxite residue, red mud is the noxious byproduct of the base process for extracting aluminum from bauxite ore. It is alkaline in nature and has a pH ranging from 10.5 to 12.5, which is one of the reasons why its concomitant disposal might lead to a number of environmental issues. If it seeps through to the groundwater, it degrades the groundwater and the soil quality, making it unfit for consumption and farming. More so because of the presence of heavy metals present in the red mud. Uh, to deal with these issues, there have been many attempts of reusing red mud for other purposes, which can mainly be categorized into water treatment, recovery of metals, and the preparation of construction materials. Many studies have examined the effect of using red mud as a substitute for ordinary Portland cement for the production of grout, pavement, geopolymer, etc. This review analyzes the leaching and heavy metal binding characteristics of these geopolymers and alkali activated binders. The leaching of these samples was examined by the toxicity leaching procedures, which also helped to identify the primary cause of efflorescence. At the same time, chemical speciation pointed out the leaching of the heavy metals from the samples under consideration. Effects of a number of parameters were analyzed, such as the various pre-treatments provided to the geopolymer samples, the effect of dosage of alkali activator, the effect of curing temperature, etc. The studies reported a heavy metal leaching concentration lower than that prescribed by the United States Environmental Protection Agency, that is the US EPA. Moreover, the leaching of heavy metals from the prepared samples was lower than the corresponding source materials. The heavy metals in the geopolymer were in the oxidizable and residual fractions, which were more stable. Hence, the red mud geopolymer mixture was speculated to be a safe alternative to cement composites. Leaching test was also performed to evaluate the activity of Al2O3 and SiO2 with varying calcination temperature and Na2O dosage. It was noted that the dissolution efficiency reached a peak for both the compounds at a calcination temperature of 800 degrees Celsius and decreased when the temperature was further increased. while the dissolution efficiency kept on rising with the addition of more Na2O. A rather higher dosage impeded the workability of the mix. Therefore, a balance is required for its optimum utilization for a certain application. Leaching tests were conducted before and after the efflorescence test to understand the mechanism of the formation of efflorescence. It was observed that the primary cause of efflorescence in the red mud containing sample was due to the amount of sodium ion present in it. Although the extent of leaching was less in the geopolymer samples as compared to the samples prepared using Portland cement. The absorption of heavy metals by the different samples prepared were studied using spectral scanning and chemical speciation. It was observed that the red mud based geopolymer uh, pervious concrete had the best absorption capacity among the samples prepared, while the order of the heavy metals adsorbed on the geopolymer surface was in the order as shown here. This property of the geopolymer pointed out its potential use for the design of pervious concrete, which could function as a water purifier. To conclude, there is an urgency to find an alternative way to use the pernicious red mud instead of using the conventional way of disposal. The study also indicates that the leaching and heavy metal binding characteristics of geopolymers and alkali activated binders were better than the samples prepared using OPC, thus suggesting that red mud can be a possible substitute for the same. Although, in order to do so, there is a need for regulations and further research is needed on the corrosion of reinforcement, bond behavior, and structural behavior of reinforced geopolymer if it is required for higher strength. These are some of the references used in the presentation. Thank you.
Thank you, Aman, for this wonderful presentation. So anyone who wishes to ask anything, they may raise their in the chat box. One question from my side, Aman. Have you gone through some research work, previous research work or experimental work done by past researchers in your study?
Yes, sir.
So what experimental data they have got?
So they have done leaching tests and leaching test and chemical speciation, and according to those data, they have predicted the formation of new bonds and the compounds that have been formed in the geopolymer or alkali activated binders, and how those bonds are affecting the properties of the geopolymer. So that has been reported in the review.
I have one question from my side. How does red mud influences the hydration chemistry in cement part?
So, in contrast to the formation, of bonds in the ordinary Portland cement, the major formation that takes place there is the CSH gel formation. But here, rather, aluminum and silicate together form a chain of molecules, and here the major gel is formed by both aluminum and alumina and silica. That is why we have the researchers have focused more upon the leaching test of these two compounds.
So do you want to say that the calcination or the calcine clays and red mud after calcine will give the same effect in the hydration chemistry of the cementitious systems?
Sir, it will not give the same thing because both the processes are different, but the end result, that is the strength and the durability and other properties that we have here, are very much comparable to those obtained by the OPC.
Oh, okay, there's one suggestion from my side, that you club your review paper for your future. You try to compare the red mud with the properties of calcine clays or limestone calcine clay systems. Okay, so then you will get a clear comprehensive difference, and when comparing with that, tell them that which one is better one, so that the researchers will not get confused if they want to use red mud or calcine clays, because nowadays I have seen BIS specifications have come for limestone calcine clay cement also. Are you aware of that?
No, sir, I wasn't aware.
Okay, so BIS specifications of limestone calcine clay cements have come. So that is why I want to tell you that whenever you are focusing on something, focus on the similar particle or similar products or similar materials, and then compare them among themselves. So that will give a more comprehensive view and idea that what does that material and how does it differ from the materials of the same family. Okay.
Okay, sir. Okay, sir.
Okay, good presentation, Vijay.
Thank you, sir.
Thank you, Aman, for your presentation. Now I would like to invite Pradeep Kuhar, paper ID 80, for uploading his presentation. Pradeep.
Good morning, everyone. Is I audible?
Yes.
Good morning to the chairpersons and the authors present here. I am Pradeep Kuhad, a PhD scholar from JP University Solan from the second semester. First of all, I would like to thank ICSMC 2021 organizers, my supervisors, JP University, to give me a platform to share my research and to enhance my research skills. Today, my topic of presentation is on the experimental analysis of silica fume on the mechanical properties of the concrete mix. First of all, in the introduction section, I have some general description along with the available literature. Then I will talk about the need of the study with specified objectives. Then we will have a discussion on materials and methodology used in the study and the results obtained. And in the last, there will be future scope of the study. As we all know that most consumable material in the world after water is concrete, which consumes a huge amount of cement. And infrastructure is the backbone of any country. And without cement, it is not possible to have a good infrastructure. Besides all the benefits of cement, it pollutes the environment, and as well as it is responsible for the health related issues to the human beings. Literatures find that cement is the most polluting industry. In 2004, Mazloum et al. Found that the use of industrial byproduct, that is microsilica fume, improves the pore size refinement and the reactivity with free lime. Whereas in 2019, Buran et al. Strengthens the past works and concluded that the silica fume influenced the strength of the concrete. Silica fume is made up of very small particles of which size is about 0.1 micron, that is about 100 times finer than the cement, and possesses a high pozzolanic reactivity. Some more works also find that silica fume helps in better bonding by producing more calcium silicate hydrate gel with decrement in the void content, and there is ultimately enhancement in the durability. And there is a lot from the study of literatures, the lot of uncertainty is there about the replacement amount of silica fume with that of cements. So here are some objectives of my study. My objective of the study is to identify a suitable replacing material which proves to be sustainable, and I also want to determine its optimum replacement amount with that of cement. But these all should be without compromising the requisite properties of the concrete mix, that is the strength parameters, durability parameters. These are the materials which I had used in the study, that is OPC 43 grade cement of Ultratech company, that is manufactured by Ultratech Cement. I had collected the locally available coarse aggregate and fine aggregate, and in the study maximum size of the coarse aggregate I had used is 20 mm, and the commercially available silica fume with the specific gravity 2.2 and the specific area is 1,80,000 centimeters square per gram. I will talk about the methodology part of the study. First of all, I had collected all the constituents of the concrete mix. Then I had designed the mix design as per the IS code, that is 10262 2019. Concrete mix Indian standard codes, and then finally I casted the specimens, that is tubes, cylinders and beams. Then all the specimens were cured for the required number of days. That I had tested some specimens at 7 days of curing, at 14 days of curing, and some specimens at 28 days of curings. Then after that, after the required number of curing days, I had tested the specimens for compressive strength, tensile strength, and flexural strength respectively. Here are the details of the mixed designs. I had costed 5 types of specimens and designated them as MX0, MX1, MX2, MX3, MX4, where MX0 denotes the conventional concrete, normal concrete, in which I do not use silica fume. Where MX1, in MX1, I replaces 4.5% silica fume by weight of the cement. In MX2, I replaces it 7% silica fume. In MX3, I replaces 9.5% of silica fume. And last, in MX4 type of specimens, I had replaced 12% of silica fume with that of the weight of the cement. Thereafter, I tested the cubes for the compressive strength, and the outcome of the specimen showed an improvement in the compressive strength. And with the addition of silica fume in the concrete, the optimum amount was figured out as 9.5% replacement of silica fume. That is, MX3 specimens showed the highest compressive strength. And when we compare with that of the normal concrete, that is MX0 specimens, at 7 days we get 41.57% higher compressive strength. And at 14 days we get 33.67% higher, and at 28 days we get 28.14% higher. So it is evident that with the addition of silica fume, there is enhancement in the early strength of the concrete. Similarly, the split tensile strength had also increased by an amount 34.42% at 7 days of the curing, and then after 14 days of the curing, it was about 29.19%, and at 28 days, it was about 23.18% higher than that of the normal grade of the normal concrete, that is MX0 specimens. In the same way, flexural strength has also increased about 45.41% at 7 days and 33.48% at 28 days. 14 days. It is 40. Sorry for the typing mistake. 33.48% at 14 days and 25.80% at 28 days. After that, it is also I observed that the MX3 specimens had achieved the target strength of next higher grade concrete. I had designed all the specimens for M35 grade of the concrete, but MX3 specimens with 9.5% replacement of silica fume with that of cement had achieved the target strength of M40 designed mixed grade concrete at 28 days of curing. And if then I compared the economical aspects of that is M35 design mix, in which I had used silica fume, and another is conventional M40 design mix. And in continuation, that economic analysis was found that MX3 design mix proves to be about 4.5% cost effective than the conventional M40 design mix specimens. So coming to the conclusion and discussion part of this study, it can be said that with the addition of silica fume in concrete, homogeneity get enhanced, but there is a reduction in the workability. So we can use superplasticizers to overcome these additional water requirements. Further, it was noted that specimens prepared by using microsilica fume have better resistance against chemical attack when placed in 5% dilute hydrochloric acid solutions for a period of 30 days. And there is an enhancement in the concrete strengths, whether it is compressive strength, flexural strength, split tensile strength. Meanwhile, we are consuming less amount of cement, therefore we are minimizing the carbon footprint also. And the optimum replacement amount was found to be around 9.5%. Now it is evident that there is a better hydration of cement particles, and the formation of additional calcium silicate hydrate gel formation makes the concrete more dense, which leads to a reduction in the permeability and enhancement in the durability. And high early value of early strength shows good indication from contractor as well as owner profit point of view so that they can certainly speed up the constructions of the structures. Um, Here are some future scopes of the study that in the near future we can add other materials into the concrete, other byproducts of the industries. Meanwhile, in the particular topic, that is silica fume, some more study is also required to analyze its long-term durability, as well as we also can compare the long-term cost, that how much cost effective is the utilization of silica fume in the concrete structures. Here, these are the references which I had utilized in my study. Thank you.
Thank you, Pradeep, for your presentation. Anyone who wishes to ask anything, questions, they may raise their issues in the chat box. We will discuss it. Till then, Pradeep, one query from my side.
Okay, sir.
First thing is that working with silica fume, with concrete, lots of work has been done by the past researchers. What's new in this study? Anything new you have done, or you are just showing the what past researchers have done?
The newness is only that, sir, in the past there is a lot of confusion about the optimum replacement level of the silica fume. Some of the authors said in the past said that we can use up to 33%, 35%. Some of them said that it is limited to about 5 to 6%. One thing I had done, that I had founded the optimum replacement level. Secondly, I had analyzed its economical aspects. I found that there is a limited analysis of the in economical point of view, and in which if we can by this study, I can certainly say that if we use lower grade of concrete with the utilization of silica fume into it, it can be alternative to the higher grade of the concrete. And sir, it reduces the pores in the concrete, which ultimately enhances the durability of the concrete.
So, have you checked the durability aspect of your concrete?
What, sir?
Have you checked the durability part of your concrete?
Yes, sir. Durability part I had checked, sir.
So,
for that, I had placed the specimens for 28 days in the 5% dilute hydrochloric acid solution, and I had found, I had calculated their weight loss, and also observed the loss in the compressive strength. The specimens with silica fume showed less decrement in the compressive strength in when we
okay, but final question from my side. Have you faced any practical problem while casting concrete with silica fume?
Yes, sir. Yes, sir. The practicality, it gets very dense, sir. Workability, if we go for heavy structures in which a lot of reinforcement is there, then we can't use high amount of silica fume, because it makes the concrete dense. तो हमें compaction करने के लिए concrete की बहुत problem होगी, so that we have to use superplasticizer. I had not used superplasticizer that, sir. Then superplasticizer can certainly enhance some cost.
Okay. Anything regarding the shrinkage part, because you are using silica fume, so that is liable to get early dry shrinkage. So have you worked on that?
Yes, sir. Shrinkage part is there, sir, but we can use some other material available. Other byproducts are also available. Metacolin can be a good alternative for this, sir.
Okay, okay. So that's all from my side.
Okay.
Anyone who wishes to ask, they may raise their issues.
No questions from my side.
Okay, okay. Thank you.
Thank you. Thank you.
Now I would like to invite Mr. K. Arun Kumar, paper ID 205,
Yes, sir.
start his presentation.
Yeah, thank you, sir. Am I audible?
Yes, you are audible.
Yeah, thank you, sir. So, good morning. I think it's afternoon. So, good afternoon, everyone. I'm Arun Kumar from Kalasaling University, which is located in the southern Tamil Nadu. Okay, my screen is visible.
Yes, yes, yes.
Yes, yeah, thank you. So I'm presenting my topic on incorporation of waste wood ash and polypropylene fiber on the production of sustainable geopolymer concrete, right? So there are my co-authors, and first of all, I would like to thank my professor, Dr. M. Muthukannan, for guiding me to do my research. And this is my research problem. Why? While the CO2 emission is the most important problem worldwide, so whereas the global CO2 emission is emitting like increasing by 10 to 50% of total global, that is greenhouse gas in 2020. And so for that we have to make over the cement usage into alternate construction materials. For that we have moved on to the GPC, and whereas GPC is a old material which is found in 1978 something, but in the GPC they are using GPC using fly ash, and in fly ash GPC there is a problem like higher alkaline solution requirement, and need of alkaline, that is need of elevated temperature curing, and the fly ash demand is increasing day by day, and it is the production of fly ash is decreasing and the demand has been increased. So there is a need of alternate binder for fly ash in GPC. So we have moved on to the new material which is known as waste wood ash, that is plenty available in the nearby hotels. So we have looked into the nearby hotels. They have used some wood waste, and that trees, cut on trees, they have used for as a fuel. After burning the fuel, they have thrown the ash into land. That is, it is most harmful. So we have taken that waste wood ash as a novel material for our research. And one more thing, in GPC there is a lack of impact and energy absorption ductility behavior of GPC. So the GPC has some problem like in the properties. So we are want to alternate that problems to advantage. For that we are adding the fibers, that is polypropylene fiber. Okay, so this is my research problem. So whereas my abstract here, why I am choosing that waste wood ash, and what is the waste wood ash, and how I am going to replace the wood ash in my research. So I am taking 0 to 100% of replacement of fly ash with the wood ash at 10% increment. And I have moved on to optimization of like fly ash and wood ash ratio. Then while doing choosing wood ash, I have noted that there is an wood ash has a chemical composition of potassium. So we are using for GPC we are using alkaline solution, which is sodium hydrogen sodium silicate. So we have chosen that K2 as a K2 can be act as an alkaline solution. So we have noted that waste wood ash has that potassium. So while our research move on to the next journal, that we can reduce the quantity of alkaline solutions. Okay, so we are optimize the molarity, and we have optimized the ABB ratio, that is solution to binder ratio, and then we have optimized the wood ash to fly ash ratio. After that we are adding the polypropylene fiber to 0 to 2%. Here we have no doubt why you are choosing that percentage limited, that is 0 to 2%. While we are referring the journals, we have noted that the fiber addition should be limited to 2%. So we have chosen that fiber addition can be added within 2%. So we have chosen 0 to 2% by 0.5% of increment, right? So this is our abstract. Then this is then some small introduction about GPC. What is GPC and what is the waste wood ash, and what are the chemical composition that is having in the wood ash. And now I move on to the objective. That is, my objective is to optimize the wood ash and fly ash ratio in the low calcium geopolymer concrete, and then I'm going to optimize the molarity of near solution. Then I'm going to optimize the solution bind ratio. Then I'm going to optimize the percentage of fiber polypropylene fiber addition. Then I'm going to find the influence of that material, that is wood ash and molarity and ABB ratio. And I have to find out the mechanical properties of polypropylene fiber in forced geopolymer concrete. So this is my objective. Then why I'm choosing that this study means it is to find the solution to reduce the CHG by the production of cement and to utilize the waste that is industrial byproducts, that is waste materials which are plenty available in the environment. So we have to dispose the waste into the innovative product. That is my main aim of this study. Okay, now these are the materials I have used and these are the material properties I will go through in this. And this is the chemical composition of fly ash and wood dust through EDX. By this we have found that waste wood dust has the potassium, that is K. Here it is here. So here we have found that K is available in the waste dust, so we can use that K. Okay, so these are the materials we have used. There's picture of materials. So NaOH, polypropylene fiber, waste wood dust, and reverse and fly ash. Then while we are choosing geopolymer, there is no specific mix design for geopolymer, but they have modified guidelines for geopolymer concrete as per the IS standard 10262. So by using this, we can design the mix proportion that we can find that M30 we have chosen for M30. For M30, we have designed as aluminum silicate material, that is binder material is 1 and 1.05 is to 1.57. That is the ABV ratio, alkaline solution to binder ratio of 0.61. Whereas the objective of our study is to optimize the binder ratio, NaOH molarity, and that ABB ratio. So for that we have optimized this. So our study follows that. So the optimization of binder replacement of wood dust by 0, 10, 20, 30, 50, 60, 70, 80, 90, and 100 by fixing the constant 13 molarity of NaOH and the 0.61 of ABB ratio. After optimizing this binder ratio, we move on to the optimization of NaOH molarity. So the molarity optimization is done by 8, 9, 10, 11, 12, 13, and 14 by fixing the constant ABB ratio of 0.61. And then we can move on to the optimization of ABB ratio, that is by 0.45555, 0.6, and 61. After optimizing all these, and we can move on to the optimization of fiber. The fiber percentage can be chosen as 0, 0.5, 1, 1.5, and 2% of weight fraction. So by this we'll these are the quantity of materials we have obtained. So this is the casting of specimens, and now we move on to the result and discussion. Whereas the result and discussion comprises of 4 parts: that influence of waste wood dust on geopolymer concrete, and influence of NaOH molarity on geopolymer concrete, then influence of ABB ratio, then influence of polypropylene fiber. Whereas the influence of waste wood dust on geopolymer concrete, it is the findings after the result. We have found that 30% of addition of waste wood dust can be has been an optimum percentage, which is observed maximum performance in all strength characteristics like compressive and tensile strength. Then the optimum mix, 30% mix has attained a maximum compression strength of 22.87 MPa at 3 days and 27.73 MPa at 7 days and 37.92 MPa at 20 days. So we have designed for M30 mix, but by the addition of wood dust, we have achieved that at 28 days we have achieved 37.92 MPa. And the same method of tensile strength, we have obtained 3.83 at 3 days and 4.26 MPa at 7 days and 4.48 MPa at 28 days. The strength increment were observed by 16% and 5.6% of tensile strength and 16% of compressive strength than the control mix, which is having the 100% of fly ash we have taken as control mix. The addition of waste wood as the percentage of increment has gradual, and this is the graph which is explained the compressive strength by the influence of waste wood dash, and this is explained the tensile strength of waste wood dash. And then move on to the influence of NaOH molarity, whereas the strength was increased by increasing the molarity. It is observed from that is inferred from the previous literatures, but the same we have obtained here. The findings also inferred that the strength increment was achieved by increasing the molarity of NaOH up to 13 molarity. So that is 8 to 13 molarity, the strength was increased. After that, the strength start decreasing, whereas over the 13 molarity. However, considering the cost overview and the waste wood as an potassium, So we can there was a need of reduced to quantity of alkaline solution and alternate for alkaline activators. For this, the 10 molarity NaOH has obtained 34.51 MPa, which is more than the characteristic compressive strength. So the 10 molarity of NaOH could achieve 100% of strength after 28 days. Hence, we can chosen the 10 molarity for our study after this. Okay. So this is the test results of different molarities, and then we are moved on to the influence of alkaline solution binder ratio, whereas the strength was increased with the increasing of A by B ratio. Based on the mixed design, the A by B ratio was 0.61, and the performance was maximum in all strength characters compared to the other ratio. However, the importance of reducing the usage of alkaline solution on GPC was mentioned earlier in the study. The mix with the 0.545 ratio has attained the strength of 32.9 kPa. It is more than the characteristic compressive strength. Hence, we can choose that 0.45 could be enough to achieve the 100% of strength after 20 days of curing. Hence, the study found that 0.545 ratio could be help in reducing the quantity of alkaline solution. Right. So this is the test results of compressive and tensile with the different ABB ratio. So we optimize three, that is optimization of AB wood dash and molarity of NaOH solution and ABB ratio. Now we move on to the optimization of fiber content, that is polypropylene fiber and the geopolymer concrete. Whereas we have chosen 0.5, 1%, 1.5 and 2% of PP fiber. The maximum compression strength of 24.49 MPa and 29.95 MPa and 42.9 MPa was achieved by the addition of 1% of PP fiber, whereas the strength increment was 61% and 47% and 22% compared to the control mix. The increment was due to the highest degree of compressibility of PP fiber, and the result findings were correlated with the previous studies. Whereas the same like compressive strength we have achieved in the tensile strength, that the maximum tensile strength was observed with the 1% addition and of 2.6 MPa at 3 days and 3.08 MPa at 7 days and 3.69 MPa at 28 days, whereas the strength increment percentage was 10%, 9.5% and 11% at respectively, right? Now, the same method of compressive and tensile, the flux strength was also optimum at the 1% of fiber addition, and the flux strength was in 3 days 3.58 and 4.28 in 7 days and 4.8 MPa in 28 days, whereas the strength increment was 8%, 10.75% and 12% on the respective days. Okay. While coming to the conclusion, whereas in the optimization of wood dash, we can find that 30% of additional 30% replacement of wood dash has been optimum, and after increasing the wood dash replacement beyond 30%, the strength decrement was noted. Hence, we have taken as optimal replacement of waste wood dash as 30%, and for the in the optimization of NaOH molarity, we have noted that strength increment was noted up to 13 molarity. After that 13 molarity, the strength increment was stopped, that is, the strength was decreased. And one more thing, in the 10 molarity of NaOH has obtained 100% of compressive strength. Hence, we can choose that 10 molarity NaOH as an optimum NaOH molarity for the future study. Then for the same method of optimization of ABB ratio, we have taken 0.45 as an ABB ratio because it is achieved 100% of strength in the 20 days compressive strength. Hence, we can take 0.54 ratio for the favor of reducing quantity of alkaline solution. And finally, in the optimization of polypropylene fiber, 1% of fiber has obtained the optimum strength. Hence, it can be chosen, and the 1% of addition of fiber can improve the tensile, compressive tensile and flux strength by 61%, 11%, and 12% respectively. Beyond the 1% of addition of fiber, reduce the strength in all strength characters. Hence, 1% can be chosen as optimum. So beyond that, I have to conclude that 30% would achieve better performance and gradual increment. So the objective of the study has been proved that the 30% waste wood ash can be used as an alternate for fly ash, which can help to reduce the quantity of alkaline solution as well as the demand of fly ash and the drawbacks of fly ash based geopolymer concrete. Thank you. So queries are welcome.
Thank you, Arun Kumar, for this wonderful presentation. Anyone who wishes to ask, they may raise their issues. We will discuss it. And so, anyone? Sudipta Ghosh has asked one question. You mentioned that about the collection of wood ash from the
Yes, sir.
different
I'll
local
answer. So thank
hotels.
you, Gupta. I think we have collected the wood dust from different local hotels. So why I am mentioning this means we are planning for the future research. That is, the waste wood dust which is collected from one hotel is different from the another one. So we can go for a research which we can summarize of different wood dash which are different wood dash we have collected, and we have researched for different properties, and we have combined that different waste wood dash behaviors in one paper, and we will publish soon.
Yeah, Mr. Arun, I have one query.
Yes, sir.
I'm just asking that does the type of wood have any effect on the ash content? Means the oxide composition of ash
Yes, sir,
content?
sure, sir. The chemical composition was differed with the type of wood dash, sir. We have, for example, we have in our research we have collected the wood dash as a three types, sir. First one we have collected from the local hotels. The second one we have collected the waste wood which is available in the timber industry, and we have burned it. After that, we have collected waste wood dust. We can give it to the into the bakery. They have heated, that is burnt the waste wood, and they given us ash. So these three types we have collected so far, and for future study we have planned for collecting other type of waste wood dust also, sir.
Okay. My second question is why you have selected wood ash, because wood is not being used as a fossil fuel anymore in any industry,
Yes, sir. But
if
the
I'm
way,
right.
yes, sir, you are right. But the timber industries are generating lot of waste, that cannot be disposed, sir. So they have sell it to the that paper mills and that local tea shops and local hotels. They have banned. After that, they are using as fuel. They have dropped it to the some ground waste, sir. So if you
Is there any authentic source which is available which states
Yes,
the
sir.
amount of
Yes, sir. Yes, sir.
wood?
There are a lot of source which is conducted using the waste routers in concrete and as well as in geopolymer concrete. I will show the number of literatures are available during using that waste routers geopolymer concrete and waste routers concrete also, sir. Already the research was done using these waste routers. Am I audible?
Yes, yes. So, thank you, Arun Kumar,
Thank you,
for
sir.
your wonderful presentation. Now, I would like to invite Manoj Kumar Punya to upload his presentation.
Is I am audible, sir?
Yes, yes, you are audible. Please continue.
And my screen also, sir,
Yes,
visible?
yes, yes.
Okay, sir. Good afternoon, everyone. My name is Manoj Punia, and I am a PhD scholar from JP University, Solan, Himachal Pradesh. First of all, I would like to thank ICSMC 2021 organizers, organizers, the JP University, and my supervisor to give me a platform to enhance my research skills and the knowledge. My topic of the presentation is experimental analysis of microsilica fume and steel fibers on the strength of the concrete mix. In that, I will discuss about some literatures in introduction section. Then I will
Manoj,
talk about the.
sorry to intervene, Manoj. Your slide are not. You have opened a PDF file, I think.
Okay, sir. I am trying again, sir. Please.
Please open a PPT. Otherwise, it's not visible.
Now this time, sir.
Yes, sir. It's okay. Continue.
Okay. Thank you, sir. Shall I start, sir?
Yes, you may continue.
Okay, sir. And in that, I will discuss about some literatures in introduction section. After that, I will talk about the need of study with specified objectives. Then we will have a discussion on the materials and the methodology and the results obtained. And last but not the least, it is the future scope of the study. As we all know that the most consumable material on the earth after water is the concrete. And in the making of concrete, cement is consumed in a large amount. And it is impossible to have a good infrastructure without the cement. But it is also evident that it endangers the human health as well as the environment. Literatures also identify the cement as most polluting industries, and in the past, lots of researchers have been done on different alternatives of cement by partially or fully replacement of cement with those materials. In continuation of that, in 2008, Lin W.T. et al. And Gyunglu also in 2008 finds that addition of fibers in concrete improves its quality. Later in 2011, Siddiqui R finds that MSF stands for microsilica fume improves the reactivity with free lime and improves the cement aggregate matrix densification. Whereas study by Coxell et al. In 2008 finds that silica fume with the addition of steel fiber have a good impact on mechanical properties of the concrete. Some more works in the past also finds that microsilica fume enhances the densification of concrete and steel fibers decreases the brittleness, thereby preventing sudden failure as well as enhances the thermal capabilities. So in continuation to the past research work, my motivation behind this research work is to validate the good alternative of cement from the industrial byproducts and which not only beneficial for the environment as well as proves to be economical as per the cost parameters. Okay, to achieve the objectives, material have been used. First, OPC 43 grade cement of Ultratech Cement Company, local available coarse and fine aggregates, commercially available microsilica fume and steel fibers with the following parameters, and stainless steel fibers with aspect ratio of 80, that is L by D, as we chosen the length of 40 mm and diameter of 0.5 mm of steel fibers. In the experimental program, first we had designed the concrete mix as per Indian Standard Code, that is IS 10262-2019, and calculate the amount of constituents of the concrete, and finally casted the specimens is that cube of size 115 to 115 to 150 mm, cylinder of size 115 to 300 mm, beam of size 115 to 115 to 700 mm. After that, those specimens were cured for 7 and 28 days respectively. Thereafter, testing was done and the outputs was analyzed. Details of each mix design presented in as shown in table 1. where M0S0 is normal concrete, where we do not use any admixtures like silica fume or steel fibers. And in case of design mix M1S1, it contains 3% of MSF as a replacement of cement by its weight and 0.7% steel fibers by the volume of concrete. And in case of M2S2 design mix, MSF replaced 6% cement's weight and SSF replaced SSF of 1.4% by the volume of concrete. In case of M3S3 design mix, MSF of 9% by the weight of cement and SSF of 2.1% by the volume of concrete. In case of M4S4 design mix, MSF of 12% by the weight of cement and SSF of 2.8% by the volume of concrete has been used. Okay, the results of the compressive strength test shows that there is a remarkable combined effect of silica fume and steel fibers on the concrete, and we got the maximum strength in case of M3S3 design mix specimens, in which we used 9% of silica fume as a replacement of cement, and similarly 2.1% of steel fibers were added by the volume of concrete, and got 41.22% higher at 7 days curing and 26.45 higher percent higher at 28 days curing as compared to the conventional concrete. In case of split tensile strength, similarly increment found as wait sir as at 7 days it is 99% higher, and at 28 days of curing it was found to be 86.49% higher. In the same way, flexural strength was also enhanced by at 28 days it was found to be 86.49% higher. By clearly monitoring the results, it was observed that M3S3 specimens has achieved the target strength of higher grade concrete, that is M40. After that, an economical analysis was made between M3S3 design mix and conventional M40 design mix, and it was found that we can save about 2.4% cost if we use M30 designed mix as M3S3 in place of conventional M40 design mix. In continuation, now we coming to the concluding part of the findings. It can be said that with the addition of MSF and SSF, there is an increment in the flabbiness of the concrete with the reduction in water bleeding. Further, MSF and SSF also enhances the denseness in concrete, which certainly reduces the workability of the concrete. Now, if we talk about the hardened properties, that is mechanical strength of the concrete, results had shown that there is a remarkable enhancement in all the strengths, whether it is compressive strength, split tensile strength, and flexural strength. And it was also found that optimum amount of cement replacement by silica fume was found 9%. Steel fibers in the concrete. Similarly, MSF and SSF provides better resistance ability to the concrete against chemical attack as well as the crack propagations. And at last, it is future scope of the study as incorporating the other industrial byproducts which reduce the cost as well as carbon emission, because it is the need of the all research nowadays. Besides this, an attempt is done by the other alternatives of silica fume is that we can use metacolin, which may prove more beneficial by considering its economical aspects. And these are my references which I had used for the research. Okay, thank you, sir. That's all from my side.
So thank you, Manoj, for your presentation. Anyone who wishes to ask, Gitu, Elsa Thomas wants to ask. Uh, I think the figure shown for split tensile test is wrong. Yes, that was also my concern, Guido, because split tensile strength figure which you have put on your slide was because you have taken a flexural beam and you have applied a compressive load. So that was also, maybe that was a mistake from Manoj's side.
Yes, flexural side is at 7 days curing was found to be 99.17% on higher side. At 28 days curing, it was 86.49% higher side.
So
Okay.
Manoj, actually the question is that you have put a wrong figure on your presentation slide showing the split tensile strength, because split tensile strength is performed on a cylindrical specimen, and you have what the figure you have shown in your slide is a beam specimen.
Split tensile strength, I think
Okay,
split tensile strength. Yes, sir.
Maybe you have put a wrong figure that you need to check on your side. Another important thing which I just want to ask is that the results which you have shown in your experimental part is very exaggerated. Have you checked it from your past research? Because 86% of high compressive strength of what you have compared from your normal concrete, it's the results are very much exaggerated. So have you checked from any past research?
Yes, sir. I studied many literatures, and they suggested that most research has achieved the mostly researches had achieved these results.
Okay. So Abhilash sir, if you wish, you can ask.
Yeah, I have one question. You have used steel fibers, right,
Yes,
Manoj?
sir.
So
Yes,
does
sir.
split tensile strength is good as an applicable test for this type of concrete? Does split tensile is
Yes, sir.
validated? Means I think it is not. Does it validated experiment for concrete with steel fibers? Just I want to know.
In case of column, sir, it is
Not
needed
column. I'm
to.
just asking about concrete. Concrete with steel fibers. Does split tensile strength give you valid good results? Does split tensile strength you correct results?
Sorry, sir. Please, sir.
I am telling you concrete with steel fibers. So you are performing split tensile strength for indirect tensile strength of concrete, right?
Yes, sir. I got
So
now.
does split tensile strength for concrete with steel fibers give correct results?
Yes, sir. Because it prevents it resists the cracks and propagation, and it also bridges the cracks,
It does
micro cracks,
not.
sir.
It does not. It does not. You please go and check in the literature. There are so many other methods to evaluate the tensile strength of steel fiber concrete, steel fiber reinforced concrete. So you need to check. Okay, beta?
Okay, sir. Yes, sir.
Chalo.
Yes, it's also my concern, because obviously if you are putting steel fibers in a concrete and you are checking the split tensile strength, so that will not give the correct result, because the cracks will get arrested due to steel fibers, and obviously that will not give the correct result. So you have to go for a different other processes which are available in the literatures, so that will give you the exact value. Okay.
Okay. Thank you, sir, for the kind suggestion, sir. I will take I will take care in this in the future works.
Okay, thank you, Manoj. Now I would like to invite Ankit Belwal, paper ID 82,
Okay,
to
sir. Thank you so
upload
much.
his presentation.
Okay, hello sir, am I audible?
Yes, yes, you are audible.
Okay. Sir, my screen is visible?
Yes, yes.
Okay. Okay, first of all, good afternoon to one and all present. My name is Ankit Belwal and I am an assistant professor at Devbhoomi Uttarakhand University, Dehradun. The title of my paper is Construction Stage Analysis of Continuous Box Girder Bridge Constructed via Full Staging and Balanced Cantilever Method. And my co-authors are Ms. Chipra Tavlial and Mr. Vipendra Singh Jankwan. As we all know that box girder bridges are quite popular nowadays for metro rail bridges as well as roadway bridges. Thus, the study of their structural behavior has a significant importance. All structures in their construction phase goes through different intermediate stages. Thus, in these stages, the load carrying capacities and mechanical behaviors, geometrical properties can vary widely. These stages will have a significant impact on the final design of the structure and stress distribution in it. Therefore, performing analysis without taking into account the process of construction may procure results that are not reliable. Thus, to incorporate the effect of these stages, construction stage analysis should be preferred over. Sir, am I audible? Can you please confirm it?
Yes, you are. Yes, you are audible.
Okay, thank you, sir. Okay, thus to incorporate the construction stage analysis, I have performed construction analysis. Just it has been found in studies that the bending moment and deflection from construction stage analysis are significantly large as compared to analysis done without considering construction stages. The difference in such results may be due to the fact that each temporary structure arrangements can lead to critical internal forces or displacement in specific members and may have effects on subsequent stages. Also, the structure behaviors such as deflection and stress redistribution continue to change during and after the construction due to the varying time-dependent properties of concrete such as creep, shrinkage, and modulus of elasticity, and also the relaxation of tendons. As we know that different construction methods have different construction stages associated with them. Thus, each method will be associated with different types of construction stages load and time-dependent properties. Therefore, the objective of this study is to compare the effect of construction stages on the structural behavior of pre-stressed concrete box girder bridge constructed using balanced cantilever method and full staging method, and thus to determine the efficient method among the two based on the analysis result. Now, if we talk about the example bridge, you can see the line diagram and 3D view of bridge model taken as an example. The bridge has a 3-span continuous cast in place box bridge having the main span length of 130 meter and 2 side spans of 85 meter each, constituting the total length of bridge 300 meter. The width of the bridge is 12.7 meter, accommodating 2 lanes. The whole structure system of the bridge constituted of a continuous bridge deck, 2 intermediate piers, and 2 end abutments. Each intermediate pier consists of 2 piers of height 40 meter and 4.2 meter center to center spacing. Midas Civil software has been used for modeling the bridge in this study. In this slide, you can see the cross sections of the bridge deck and piers as shown. The bridge deck consists of a tapered longitudinal section with varying depth, such that it has maximum value of 7 meter over the piers and a minimum of 2.7 meter at the abutments and mid spans. And the B part of the figure shows the cross section of piers. Now, talking about the construction stages involved in balanced cantilever method, In this method, the bridge is constructed in number of stages, constituting erection of piers, cables, and deck segments. This method has been preferred over other methods as it does not require any scaffolding. In the earliest stage of this method, piers have been constructed and formwork and scaffoldings are arranged for pier table constructions. In the next stage, formwork traveler is positioned to cast segments on both sides of pier. That is why it is called a balanced cantilever method, because we construct cantilevers on both sides of the piers. After that, the formwork traveler is installed in this recently casted segment and positioned to carry formwork for new segment. This process is repeated and all segments are casted one after another. After this, at last construction stage, the mid-span cantilevers and side spans are joined together using key segments. And to take account of time-dependent analysis due to creep, the last stage is given a duration of 10,000 days so as to check the long-term effect of creep strains. Now, if we talk about the construction stages involved in full staging method, it is basically a traditional method of constructing bridges, which involves the use of proper false work arrangements for casting bridge deck, piers, and other structural components. As the length of the continuous tendons have some limits, which will therefore be handled with the construction joints. Thus, in this case, construction stages have been considered based on these construction joints. The construction joint is provided after the completion of each span. Thus, all the three spans are constructed sequentially on their respective construction stage. Now, moving on to results and discussion. Here, the graphs are showing the bending moment variation throughout the bridge deck for the case of balanced cantilever construction and full staging method of construction. From the graph, it is clear that the maximum value of bending moment is more in case of full staging method comparative to balanced cantilever method. This results may be due to the more number of segments casted individually in case of balanced cantilever method. Now, next graph, this graph is showing the variation of shear force along the bridge span for both the methods. There is not much significant difference observed in the maximum positive and negative values of shear force in both the cases. But in comparison, balanced cantilever method have lesser values of shear force. And then moving on to next slide. These graphs are showing the variation of axial force along the bridge deck for both the methods. From this, it is quite clear that negative axial force have quite larger value for the case of balanced cantilever method as compared to full staging method. But we can also see that in case of balanced cantilever method, axial force are higher near the piers and have lesser values in the middle of the spans. But in case of full staging methods, the actual force values are basically constant throughout the bridge deck and have maximum values near the piers. Now, to conclude my presentation, from the results, we have seen that the maximum values of bending moment are more in case of full staging method of construction, about 5 times of the value in case of balanced cantilever method. The negative bending moment is also more for full staging method of construction. Such difference may have arisen due to the less efficient consideration of effect of time-dependent properties material in case of full staging. The values of shear force along the full bridge span are less in the case of balanced cantilever method, but there's not much significant difference in both the values. Axial forces are more effectively distributed in case of balanced cantilever method, but have maximum values greater than full staging method. Thus, it can be concluded that bridge deck is subjected to much lesser loads and moments in case of balanced cantilever method comparing to full staging method. Thus, adopting this method of construction can be a better alternative of construction compared to full staging method as based on the analysis result. With this, I will conclude my presentation. Thank you all for the attention.
Thank you, Ankit, for this wonderful research work.
Thank you, sir.
Anyone who wishes to ask, they may raise their questions in the chat box. We will discuss it. One question from my side, Ankit. What type of loading you have applied?
Sir, apart from construction stage loaders, I have also applied the self-weight of the structure. Those are basic loads, self-weight and superimposed dead loads like loads of parapet walls and road coverings, surface course. And other than this, pre-stress load is also applied on the structure. And apart from this, temperature stresses, the effect of temperature on the bridge structure is also considered in this study.
What type of live load is there?
Sir, live load is not considered in this study.
Okay, only dead load you are considering.
Yes, sir. Only dead loads and construction stage loads.
What is expected if you increase if you include the live load? Then what is expected from what changes is expected from your research work?
Sir, if we include the live load, I don't think there can be a much difference in both the methods because live loads are not creating any significant impact on both the loads. They have increased the value of moments, but the results will be same for both the cases. The main difference which are coming from the method is because of the time dependent properties of concrete and the construction stages followed in both the methods.
Okay. So thank you very much. I don't think that there is any questions from the audience. So thank you, Ankit,
Yes, sir.
for this
Thank you very much.
presentation. Now I would like to invite Rajesh Kumar, paper ID 274, and this one will be the last for this technical session. So please, Rajesh Kumar, you are.
Am I audible?
Yeah, you are audible.
Okay, thank you.
Ankit, you please stop your presentation. Okay.
So is it visible now? Is it visible?
Yes, it's visible. Please continue.
Okay, thank you. So good afternoon, everyone. Myself, Rajesh Kumar, working as senior scientist in CSIR CBRI Roorkee, and today I will be presenting the recent progress in few newer cementitious binders and the ongoing work in CSIR CBRI in a project which is funded by MOEF in June 2023, which is continued till June 2023. So firstly, the outline will be, I will discuss briefly about the introduction, then newer binders for 21st century eco cement using waste, R&D work conducted at CSIR CBRI, some experimental materials method, synthesis protocols, microstructural modeling and hydration modeling part in very brief and followed by conclusions. So as an introduction, as we know that India is currently the second largest consumer of cement behind China, and as per Mineral Commodity Survey 17, it is estimated that about 4,100 million ton of cement has been produced, and out of which India contributes for 300 million ton. And it is expected that about 6 to 10% annually the demand for cement will grow, and the market is expected to double every 8 to 12 years. So you can see here the projection graph, which is taken from the same bureau website. So these are few news clipping in which you can see that nowadays there is demand to develop the low energy, low carbon cementitious binders. Hence, urgently a serious thought is essential, not only to use low grade industrial waste that we are using in CSIR CBRI, such as low grade limestone, red mud, phosphogypsum, etc., to develop newer binders such as CSAB binder and low carbon OPC binders for production of quality cement, but also to minimize the clinkering temperature, to use alternative binders and to reduce carbon footprints. So I will discuss some binders like LC3, as we know that this is the recent trend, and a lot of development has been taken place in the recent 6 to 7 years. Then followed by CSAB, that we are working here in CSIR CBRI, then alkali activated cement, that is also known as geopolymer cement, RBPC, that is reactive belite rich Portland cement, MGO cement, BYF cement, CCSC cement, CSA, and Calatment cement. So LC3, as we know that it contains about 50% of clinker, 30% of calcined clay, which has which should have the kilonite content more than 50% for better performance, 50% of limestone, and 5% of gypsum. And it has been found that the durability property of this cement have been superior than the other kind of cement, especially in chloride and sulfate exposure, and with the reactive aggregates too. So these are some research findings conducted by various researchers, and conclusively it has been concluded that the replacement of OPC clinker with low-grade limestone and clay in LC3 blends will minimize cost and environmental benefit of that impact also. So this is CSAB cement, which generally forms at a relatively lower temperature, about 1200 degrees centigrade, and it contains basically the yeelamite phase, about 35 to 70%. That is the replacement of halite in case of OPC cement, and which contributes to early age strand development. Then the second major phase is beta C2S, and then ferrite that phase. So different kind of industrial waste has been utilized as primary raw feed clean materials to synthesize the CSAB cement, such as aluminum rich sludge, CFBC ash, CCR residue, etc. As you can see here. AAC cement, which is known as geopolymer cement, a lot of development has been done, although some cost issues there. So AAC contains high amount of aluminosilicate as binding phase, and it doesn't require water and to hydrate aluminosilicate, and it forms the 3D polymeric structure and bind the aggregate and the coarse aggregate and the fine aggregate. So you can see here the research findings from various researchers. Next is RBPC reactive belite rich, which contains higher amount of belite and lower amount of halite. So the lime saturation factor decreases from 100 to 75% in this type of cement, and the energy requirement about 12% reduction, and reduction of CO2 emission by 6%. Next is the newer binder is Mgo Based Cement, and which comes in two forms, that is magnesium carbonate and magnesium silicate, which forms Bauxite and magnesium silicate hydrates. And you can see here that the main binding phase formed are given here in the last point. Next is belite, yeelamite, ferrite phase. As the name suggests, the major phases are belite, and followed by yeelamite, which is also present in CSAB cement, and the ferrite. And the hydration reaction forms majorly the stradlingite and catotite. CCSC, and similarly you can see here the CCSC cement and the other cement also, Lightman cement, which I have not involved here due to time constraint. Directly I will come the eco cement developed here via synergistic use of low graded industrial waste. You can see here the lab prepared eco clinker from low graded waste. This is the project which is funded by MOEF, and in which we are targeting development of low energy, low carbon binders via synergistic use of low graded this industrial waste for sustainable development. So our R&D work, which is ongoing, is influence of raw mix composition, their fineness, and the inclusion of fluxes such as calcium fluoride to reduce the sintering, clinkering temperature and different burning temperature on clinker property. The correspondence between the predicted phases composition and the real phase composition based on the modeling, the influence of quantities of different phases on hydration behavior and stand development, and the evaluation of phases on the basis of refinement and QXID, etc. And we are also studying the phase diagram study followed by thermodynamic modeling. So prior to that, I have visited the many cement plants, and if you like, you can see here Mangalam cement plant, and from where we have procured that low grade stone slurry that we are using to replace marginal grade limestone and clay, and along with we are also replacing high grade limestone. So before that we have assessed the property as per European code, that determines the properties for limestone fines to be used as raw feed clean material. So different properties such as methylene glue index, clay content, etc. through titration method we have determined after calcining up to, you can see here that up to half hour, 1, 2, and 4 hours. And it has been found that if the low grade limestone will be reactive, will be thermally activated, then it will generate the reactive properties which was assessed through isothermal calorimetry and the line code, that is IS 712. So we have found that the cumulative heat by inclusion of inert and reactive stone waste, it was found that with the 10 percentage of thermal activation limestone slurry, the cumulative heat was increased, and also setting time was reduced due to its reactivity and compressive strength of that lime that we have produced through the thermal activation of that low grade limestone slurry. At 14 days and 28 days, it was more than that 3 MPa, which is the optimum limit as per IS 712. So, by replacement of thermally activated low-graded limestone waste along with the gypsum, we have replaced ranging from 5 to 35% as per European code, which is European 195 Part 1 and Part 3, and we have developed the composite cement and which were compared with the LC3, OPC 43, and PPC, which is the same family almost. The second objective was the synthesis of eco cement using the low graded waste. You can see here low grade slurry, red mud, gypsum byproduct, and fly ash. So firstly, we have determined the XRF composition for the synthesis and mixed design, and then we have determined the hydration modulus, silica modulus, alumina modulus, and land saturation factor. On the basis of these 4 factors, and by Excel program, we have designed the 75 mixes, and using some time temperature curves at different soaking time, different dwelling time, and heating rate, we have synthesized the cement. You can see here the curves, isothermal calorimetry, and QXID curve we have also determined for phase quantification. After that, we have also conducted the hydration modeling on the Linux platform, in which the generation of particle distribution in the microstructure, then the distribution of phases within the particle in the microstructure, and after after applying the cellular automata and diffusion precipitation, a lot of things going on, and the result I will directly show, which is this one at different water binder ratio and at different that is without thermal activation, with thermal activation, and with no filler. So we have found that the degree of hydration was increased when we included that low grade limestone, whose fineness was more than about 300 meters per kg. So this is the modeling data in which we have found that by inclusion of active filler and at the constant degree of hydration 0.8, the formation of binder, that is CSH and pozzolanic gel, was more than that of the other two. In summary, this presentation concludes about the 9 alternative cement has been discussed, and their production process, phases, raw material composition, etc. Some of the binders such as CSA can replace conventional OPC clinkers, and a result of series of experiments performed on the cement paste were presented also. And there is some need to establish cement standard and practical guidelines to use newer binders such as CSAB cement, which are not available in India. Although China and other countries are using those kind of cement, but in India it is not much so popular. So ultimately, to meet our the sustainable development goal in cement production, the suitable techno-economical strategical planning vision from industry owners are much needed in the current industrial 4.0 scenario. Thank you, everyone.
Thank you, Rajesh, for this extensive work. I would say that you have included the experimental part as well as a numerical modeling type program also. One query from my side, you have shown in your slide about the numerical programming model.
Yes.
is that done on any software, or is that program has been done on your part?
Yes, actually, this program was initially developed by Delft University, but it was specific for their binder that they have developed. But for our binder, in which we are replacing some kind of waste material, so I have changes on the Linux platform, and some changes have been done as per the binder that we are developing.
Okay, okay. That means you are basically changing
Yes,
the
yes, yes.
programming part of the software.
Yes, yes, yes.
Okay, okay. Thank you.
Thank you.
Okay, I have one question from my side.
Yes, Abhilash.
Rajesh, I would like to congratulate for a good and extensive work.
Thank you.
I like the approach. But I would like to ask, how did you quantify CSH?
CSH quantification that we have done according to the XRD ritual refinement. So according to that, we are.
Is it reliable? Is it reliable? XRD quantification is reliable? I don't think so.
Yeah, it is somehow not reliable, but right now that in our lab.
There are other methods. Why didn't you go for some other methodology? Like
Yes, yes.
like
Yes.
some X-ray method is there.
Please tell me so that I will more refine this work.
Just I will let you know in the chat box.
Sure.
Method is it is activation. The method involves the activation of silica nuclei.
Okay.
And it is done at different magnetic levels.
It is
has
something NMR, something kind of thing, or
NMR. Yeah.
Okay.
Nuclear magnetic resonance. Yeah, NMR technique.
Okay, thank you.
Thank you for correcting me. NMR. I was not I just forgot the technique name.
Thank you.
NMR. It involves the activation of the silica nuclei. That is also not very accurate, but somehow reliable.
It is some
then XRD.
Okay. I will include that part also. Thank you.
And if you include that and communicate it to a good journal, I think it will get accepted also.
Okay, thank you for your advice and suggestion.
Yeah. Okay. Which lab you're working in, CSRI?
CSI at CBRI Roorkee.
Roorkee, you're working under which professor?
Under that Professor N. Gopalakrishnan, who is the director of this lab.
Okay. Take care.
Okay, thank you, Rajesh.
Thank you.
Now this technical session is over, and we will meet again at 2:30 p.m. for technical session 2. And in that we will be having 8 papers, and they are from the eminent authors across the globe. So I would like all my participants and other authors to please listen to that technical session 2, so that they can actually explore lots of things in their research work. So this is all about this technical session 1A. Thank you very much for your patience and for your beautiful and excellent research work. Thank you.